blocks of ice broke off from an Antarctic ice shelf, revealing an ecosystem on the seafloor that has never been accessible to humans.
Scientists aboard this international research vessel were on a mission exploring the Antarctic Ocean.
Scientists aboard this international research vessel were on a mission exploring the Antarctic Ocean. Scientists just watched an iceberg the size of Chicago break away from Antarctica's George VI ice shelf, and 12 days later, they sent a robot down to see what had been sealed beneath 500 feet of ice for centuries. The robot descended to 1,300 meters depth. The cameras switched on, and what appeared on those monitors made Dr. Patricia Eske go completely silent. Something was moving in the darkness. Multiple shapes, large organisms drifting through the camera frame, small creatures scattering across rocks, movement everywhere. The pilot increased the ROV's lights, and the entire research team saw something that wasn't supposed to exist. Life everywhere, thriving. Share this with everyone you know, because the iceberg designated A84 caved from the George VI ice shelf on January 13, 2025, exposing 209 square miles of seafloor that had been locked away from sunlight, from surface nutrients, from everything that sustains ecosystems for possibly hundreds of years. And what was living down there in that frozen darkness breaks every rule about how life actually survives. Giant sponges, nearly a meter tall, forests of coral, octopuses, icefish, sea spiders the size of dinner plates, a giant phantom jellyfish with oral arms stretching 33 feet, all of it flourishing in conditions textbooks said were biologically impossible. Before we break down exactly what species the robot filmed, how they survived without sunlight for centuries, why scientists now believe Europa's ice-covered oceans could harbor life, and what this discovery reveals about the limits of biological adaptation, make sure you subscribe to Vault of Discovery. We're giving you the real science that rewrites what we thought we knew. The numbers are staggering. The iceberg measured 19 miles long by 11 miles wide, approximately 510 square kilometers, roughly the size of Chicago. It caved from one of the massive floating glaciers attached to the Antarctic Peninsula ice sheet in the Bellingshausen Sea. Satellite imagery captured the moment. NASA's Terra and Aqua satellites watched as A84 broke free and began drifting through coastal currents. The potato-shaped berg ricocheted off parts of the Antarctic coastline over the following weeks, and beneath where it had sat, possibly for centuries, lay an expanse of seafloor that had never been accessible to humans. Think about what this actually means. That seafloor had been sealed beneath ice thicker than a 50-story building, no sunlight penetrating the darkness, no photosynthesis possible, surface nutrients completely blocked by 150 meters of solid ice, temperatures hovering near freezing, pressure that would crush steel. Everything marine biology understood about deep-sea ecosystems said life here should be minimal at best, sparse organisms barely clinging to survival. But here's where pure luck changed everything. An international team aboard Schmidt Ocean Institute's RV Falker 2 was working in the Bellingshausen Sea when A84 calved. They were studying deep-sea biodiversity, collecting sediment samples, analyzing ocean currents in the region. The research vessel was restricted to a smaller area than originally planned due to unexpected sea ice blocking their route. Then word arrived about the massive iceberg breaking free. We seized upon the moment, changed our expedition plan, and went for it so we could look at what was happening in the depths below. Dr. Patricia Eske from the Center for Environmental and Marine Studies at the University of Atacama recalled, "The decision was immediate. 12 days after A84 broke away, they reached the newly exposed seafloor. They became the first humans to investigate an area that had been locked beneath ice for an unknowable span of time. What nobody anticipated was what they were about to find. The expedition deployed ROV Sebastian, Schmidt Ocean Institute's remotely operated vehicle equipped with high-definition cameras, sampling arms, sensors designed for deep-sea documentation. The robot is tethered to the research vessel by cable, transmitting live video feeds while pilots control its movements through crushing depths humans cannot survive. For 8 days, ROV Sebastian explored the seafloor at depths reaching 2,300 meters, and what it filmed defied every prediction. The first images came back. Scientists leaned closer to their monitors. Then someone gasped. The seafloor wasn't barren. It wasn't sparse. It was covered in life. Large sponges, some nearly 230 meters deep, clustered across the rocks. Massive organisms that had clearly been growing for decades, possibly centuries. Sponges grow slowly, sometimes less than 2 centimeters per year. The size of these specimens suggested something extraordinary. This community had been active for an unknowable span of time beneath its icy roof. Then came the revelation that shattered assumptions about Antarctic ecosystems. Anemones clustered around the sponges, solitary hydroids, relatives of corals and jellyfish that don't form colonies, drifted through the current with tentacles splayed. Brittle stars climbed across sponge surfaces, deep-sea coral stalks rose from the sediment. But the larger creatures proved even more shocking. Octopuses resting on the seafloor at 1,150 meters depth. Icefish, Antarctica's cold-adapted fish species with antifreeze proteins in their blood, swimming through the darkness. Giant sea spiders moving across rocks. Crabs, amphipods, krills swarming around the ROV's lights. And then the cameras captured something that made the entire team stop. A giant phantom jellyfish. The bell, the umbrella-like body, measured more than 1 meter across. Its 4 ribbon-like oral arms stretched more than 10 meters in length. 33 feet of tentacles drifting through water that had been sealed from the surface world for centuries. Think about what this means. Deep-sea ecosystems typically rely on nutrients from the surface slowly raining down to the seafloor. Dead plankton, decomposing organic material, the constant gentle snow of biological matter sinking from sunlit waters above. But this ecosystem had been covered by 150-meter thick ice for centuries, completely cut off from surface nutrients. No photosynthesis possible, no food chain originating from sunlight penetrating the water column. So how are these creatures surviving? Here's the first shocking twist. The team suspects ocean currents are transporting nutrients beneath the ice shelf. Submarine rivers flow both to and from this part of Antarctica. The glacial meltwater from George VI ice shelf itself may be carrying suspended organic material, microscopic particles, dissolved nutrients, chemical compounds processed by bacteria that sustains life in this sealed environment. The fact that we found long-living species suggests that indeed the lateral transport, which mostly consists of glacial meltwater from George V ice shelf, could be the source of the nutrients sustaining the thriving life found under the newly exposed ice shelf, explained expedition scientist Laura Simile from the University of Cambridge. But that explanation only makes the discovery more terrifying from a biological perspective, because it means these creatures evolved survival strategies that don't match any ecosystem humans have studied before. They're feeding on nutrients transported horizontally through the darkness rather than vertically from the surface. They're thriving in eternal night. They're reproducing, growing, building complex communities without any connection to the photosynthetic base that supports virtually all other life on Earth. Then came the second devastating revelation about biodiversity. The team documented 23 distinct megafaunal species during their 8 days of exploration, and that's just what was visible to cameras. Microbial communities living in sediments, tiny organisms colonizing sponge and coral surfaces, potentially entirely new species adapted to this unique, sealed environment. Based on the size of the animals, the communities we observed have been there for decades, maybe even hundreds of years, Dr. Eska stated. The specimens they're examining back in laboratories may represent species never before described by science. Patricia Eska herself inspected a suspected new species of isopod sampled from the seafloor, a crustacean that may exist nowhere else on Earth. It will take scientists years to describe all of the new species found during this expedition, the research team acknowledged. Think about the evolutionary implications. Antarctica has been isolated for millions of years by the Antarctic Circumpolar Current, a massive ocean current that surrounds the continent like a moat around a castle. Species that evolved beneath Antarctic ice shelves have been cut off not just from surface ecosystems, but from the broader ocean itself. The third twist changes everything about what this discovery means for understanding life's limits, because the existence of this ecosystem beneath centuries-old ice proves something that astrobiology has been hypothesizing for decades but could never confirm. Life doesn't need sunlight to thrive. It needs energy. And if that energy comes from chemical processes, from ocean currents transporting dissolved nutrients, from geological activity beneath the seafloor, then photosynthesis becomes optional rather than necessary for complex ecosystems. Because the Bellingshausen Sea is not much explored in terms of deep-sea biodiversity, we expect many new species from the expedition, researchers noted. But the implications extend far beyond Earth. Europa, one of Jupiter's moons, completely covered by ice, potentially 100 kilometers thick. Beneath that ice lies a global ocean, kept liquid by tidal heating from Jupiter's gravity. For years, scientists have speculated that life might exist in Europa's ocean, but the skepticism always centered on one question: how could life survive without sunlight in an ocean sealed beneath kilometers of ice? The answer just appeared 1,130 meters beneath Antarctica. If ecosystems can thrive beneath 150 meters of Antarctic ice shelf for centuries, fed by nothing but nutrients transported through the darkness by ocean currents, then Europa's ice-covered ocean becomes not just theoretically habitable, but genuinely plausible as a refuge for extraterrestrial life. Think about how this reframes the search for life beyond Earth. Every model, every assumption about where life can exist just expanded. Ice-covered moons throughout the solar system, Europa, Enceladus, Ganymede, suddenly become not just interesting targets for exploration, but potentially active biospheres that have been flourishing in darkness for billions of years. But what the research team discovered next proves the ecosystem beneath A84 faces an existential threat now that its icy roof is gone. For centuries, possibly millennia, these creatures lived in stable conditions: constant temperature, constant darkness, nutrients delivered by predictable ocean currents flowing beneath the ice. Now, the ice is gone. Sunlight reaches the seafloor for the first time in potentially hundreds of years. Water temperatures are changing. Current patterns are shifting as the massive iceberg drifts away. The entire physical and chemical environment that sustained this ecosystem is being disrupted in real time. We seized the moment because we wanted to understand what was happening as the ecosystem transitions from being ice-covered to ice-free, Dr. Eske explained. The team collected sediment cores, water samples, biological specimens. They're racing to document this ecosystem before it transforms into something completely different or disappears entirely. Consider how climate change accelerates this process across Antarctica. The Antarctic Peninsula ice sheet has been shrinking and losing mass over the last few decades. As global temperatures rise, ice shelves fracture more frequently. Massive icebergs cave and drift away. More sealed ecosystems are being exposed to open ocean conditions for the first time in thousands of years. The ice loss from the Antarctic ice sheet is a major contributor to sea level rise worldwide, said expedition co-chief scientist Dr. Sasha Montelli from University College London. Our work is critical for providing longer-term context of these recent changes, improving our ability to make projections of future change, projections that can inform actionable policies. But what scientists discovered about timing reveals how close humanity came to never knowing these ecosystems existed. In 2021, British Antarctic researchers drilled through the Filchner-Rana ice shelf and found hints of bottom-dwelling life clinging to a boulder. But the view was limited to whatever the drill hole happened to land on. The Failure 2 expedition was the first to use an ROV to explore sweeping landscapes containing abundant life in this remote environment. The first comprehensive survey, the first high-definition documentation of an entire ecosystem beneath a recently calved ice shelf. Being right there when this iceberg calved from the ice shelf presented a rare scientific opportunity, said Schmidt Ocean Institute Executive Director Dr. Jyotika Vermani. Serendipitous moments are part of the excitement of research at sea. They offer the chance to be the first to witness the untouched beauty of our world. Think about the odds. An international research team working in one of the most remote regions on Earth. An iceberg the size of Chicago breaking free. The team pivoting their entire expedition plan within days. Reaching the site 12 days after the calving event. Deploying an ROV capable of filming at 130 meters depth. All of it aligning perfectly to document an ecosystem that had been sealed from human observation for potentially hundreds of years. Good luck played a huge role, we cannot deny that, Essett acknowledged. But there's also value in daring to explore the unexplored. Then the final game-changing truth emerged from the sediment analysis. The researchers collected long gravity cores, cylindrical samples drilled from the seafloor that preserve layers of sediment like pages in a geological book. Each layer represents a different time period, different ocean conditions, different climatic regimes. Those cores are being analyzed now. The data they contain will reveal how this ecosystem evolved over thousands of years beneath the ice, how it responded to past climate fluctuations, how ocean currents shifted, how the ice shelf itself grew and contracted through previous warming and cooling cycles. The newly exposed Antarctic seafloor also allowed the international team to gather critical data on the past behavior of the larger Antarctic ice sheet. Researchers noted understanding how ice shelves behaved in the past helps predict how they'll respond to future warming. One thing is absolutely certain. Scientists deployed ROV Sebastian on January 25, 2025 and discovered a thriving ecosystem beneath Iceberg A84 that had been sealed under 500 feet of ice for centuries. The robot filmed giant sponges, coral forests, octopuses, icefish, sea spiders, and a giant phantom jellyfish with 33-foot tentacles, all flourishing in eternal darkness. The discovery proves life can survive without sunlight and makes Europa's ice-covered ocean a plausible habitat for extraterrestrial life. As Antarctica's ice shelves continue calving, dozens more sealed ecosystems may be exposed, each one potentially forcing us to reconsider where life can exist and how it adapts to Earth's most extreme environments. Stay tuned. Amazing discoveries. Make sure to subscribe and hit the bell icon. Share this video with friends and join the discussion on what these findings could mean. Your thoughts and questions are important, so let's explore incredible mysteries together.